3.1, relationships between lines. We have parallel lines. And if I was to look at this picture right here, there is a symbol that they use to make sure you always know they're parallel lines, and they have these triangles on them right here. Every time that you see that little triangle right there on the lines, they're telling you that those lines are parallel to each other. Two lines are parallel and coplanar that do not intersect. They're never going to intersect. They have the same slope. They're going to go to space in infinity with the same slope. They'll never intersect each other. Skew lines are lines that do not intersect and are not coplanar. They're not even in the same plane. Skew lines will never intersect because they're not in the same plane. Parallel planes would be like U and V. You have two planes that are parallel to each other. They're never going to intersect. Let's see, they say CD and BE are skew lines. And so you have this line right here, CD, in this plane, and then you would have another plane going this way that that line would be on. And because they're in different planes, they're never going to intersect. So if you look here, it's got dotted lines there because they're not intersecting. These are intersecting, these two lines right here at point B, but not CD. So now we got to talk about the notation that we need to use to write that AB, line AB. We know how to write that because we were using that, is parallel to line CD. You would write it like this. You would say line AB is parallel to line CD. And we did that with slope lines. In algebra, we would write that slopes were parallel to each other by using that parallel symbolism. So you can also have segments. It doesn't have to be the whole line that's parallel to each other. You can just say part of a line, so only from A to B. Right here is parallel from C to D. So those are line segments. Or you can say lines by putting the arrows on them. All right, let's practice some of this in the next example 1, identifying relationships in space. Think of each segment in the diagram as part of a line. Which of the lines appear to fit the description? A says parallel to AB, and it contains D. So I'm looking at D, and then I'm looking at line AB. Start with that. D and AB. Which of the lines appear to fit the description? Parallel to AB, and it contains the point D. So here's AB, and here's point D. What would be parallel, Boston, then to AB? Exactly. And so you could say that DC. So we could say that AB is parallel. Line AB is parallel. Is it line CD or just segment CD? What do you think? It is just a segment because it stopped at both ends, whereas on this side, they actually have arrows on the ends of those lines. So you could say that line AB is parallel to segment CD with just a line above it. And it contains the point D. Very good. Okay, perpendicular. Was there anything on here that talked about perpendicular? What does perpendicular mean? Can you draw next to B right here what it would look like to be perpendicular? Exactly. So perpendicular lines, perpendicular. Perpendicular means that you have lines that are intersecting, and that can go all the way through. They're intersecting at a 90-degree angle. All right, now that we know what perpendicular means, it says it's perpendicular to AB and contains D. What would be perpendicular to line AB and contain the point D? Here we go. This would contain point D, and it's the corner of a box. We know that that's going to have a right angle there. It's kind of hard to tell because it's at a slant, but a square has right angles. We know that from area and perimeter. So this would be where a line would be perpendicular to AB. So DA, you would say that AB is perpendicular to DA or AD. There's that symbolism for perpendicular. It's just an upside down T. So parallel lines and perpendicular lines have to be in the same plane. Skew lines are not in the same plane. C says you want a skewed line to AB that contains point D. So it's not in the same plane now. If it's in the plane, it's either going to be parallel or it's going to intersect. Those are the only choices when you're in one plane. Skew lines are not in the same plane, therefore they will not intersect. What would be a skewed line to AB that has point D? AD is in the same plane. CD is in the same plane, but HD is in this plane here or on the side plane here. So DH would be a skewed line to AB. So I'm just going to put DH. I don't have a symbol for skew. So I'm just going to put DH then. Now it says to name the plane or planes that contain D and appear to be parallel to plane ABE. Plane A, B, E. So plane ABE is on the back side here. ABE is there. Now I need to go back and read it again now that I know where that plane is. Name one plane or more than one plane that contains point D that appear to be parallel to this plane. Can you say that again? CGH, yes, would be on this side, and that would be parallel to both sides, the other side. You're looking at both sides of the boxes. So you said CGH. Angles that are formed by a transversal. So the transversal, I have these two lines right here. Okay. And then you're going to have, notice it says T right there. That's the transversal. One line called a transversal is intersecting two other lines. We have 4 kinds of angles that we're going to use for the entire chapter. But today we're just learning about the angle names and what it means. The 4 names that we want to learn today, we're going to use these all the time. These are like free angles. Vertical angles, that's free. Vertical angles are congruent. That's forever your free information. A supplement means 180. That's free information. And then complementary angles are 90 degrees. That's like all the free information you get to draw from all the time in geometry. Here are 4 more angles that we're going to be using for this chapter. The first one is called corresponding angles. Angles in the same position means they're in the exact same place. 1 and 5 are corresponding. 1 is on top of the line, and it's on the left-hand side of the transversal. So it's on top of this line, and it's on the left-hand side of the transversal. That means that 5 must be on top of the other line and on the left-hand side of the transversal. They're in the same position. That's why they're called corresponding. Can you name another set of corresponding angles in this picture? What corresponds to 4? Angle 4 corresponds to which angle? 8, because it's on the bottom of the line and they're both on the right-hand side of the transversal. How about angle 2, Brandon? Angle 2 is on top, angle 6 is on top, and they're both on the right-hand side of the transversal. So 2 and 6 would be corresponding angles. One more, Boston. Angle 3 corresponds to which angle? 7 is on the bottom, and it's on the same side of the transversal. So 3 and 7 would be called corresponding angles. That's the first angle. The next one that we're going to look at is alternate exterior angles. Now they're alternating. They're not on the same side. So here's my transversal. Alternating means one's going to be on one side and the other one's going to be on the other side. So alternate. Then it says exterior. If I asked you where the exterior of the car was, what would you tell me? Are you on the inside or outside of the car? Exterior means to be on the outside. So what are we on the outside of here? We're on the outside of the 2 lines. Okay, so exterior means to be on the outside of those 2 lines. And then alternate means to be on each side of the transversal. All right, it says that 1 and 8 are alternate exterior angles. 1 is on the left, 8 is on the right, and they're both on the outside of these 2 lines, of the skew lines. So 1 and 8 are considered alternate exterior angles. How many other alternate exterior angles? We had 4 corresponding angles. How many alternate exterior angles will we have for this picture? 2. There's only two. We have 1 and 8 are on the outside and alternating, and then we have 2 and 7 are on the outside and alternating. That's it. You only have 2 sets that are on the outside. So you have 2 alternating exterior angles. All right, how about alternate interior? See, it's the same thing, but this time it's the interior. They're alternating, but this time, what does it mean to be interior? You're on the inside of the lines. So we have 3 and 6 are alternating, and they're on the interior of the 2 lines. What other do we have? Think about it for a second. Don't say anything out loud. I want you to think of another set of alternate interior angles. Give me a thumbs up when you're ready to go. 4 and 5. So I'm just going to highlight 3 and 6. And I'm going to come back here and highlight 1 and 8, just so I can visually see, and then corresponding 1 and 5. I kind of like to look at sometimes, just have it pop right out. All right, so alternate exterior, alternate interior, those are very similar to each other. The next one is called consecutive interior angles. Now, consecutive interior angles, where are they found on the 2 lines? Are they found on the inside or on the outside? It says interior, so I know I'm looking on the inside right now. I wonder what consecutive means. I know it can't be alternate because that would be alternating. What do you think consecutive is going to mean then on the inside? Give me, it says that 3 and 5 are consecutive because they come one after another. Consecutive and on the inside. So today we're just getting used to the angle names. All right, so we still have time. Let's practice a construction. Draw a line, but we are going to label it point P. As I was saying, in most constructions, you need to find an equal distance to mark off from. And that's where AB is going to come into play right now, is we need to find an equal distance from that point that's not on the line. And so you're going to take your compass, put it on point B, and extend your compass so it will cross that line twice. So I'm just going to make an arc across the line. Go this way and this way. It looks like I'm going to have to extend my line a little bit because I didn't hit it twice. So I'm just making an arc, and again, I'll have to extend it. I'm creating 2 new equal distance points from P. And so I just go back, line this up. And those 2 new places are going to be AB. Those are my 2 equidistant points from P. Keep that same measurement. Don't mess up your measurement. If you did, just go back to point P and find that measurement that you just used. You have to have that same measurement. If you used your compass to write with, you need the same measurement. So just go back to point P and find it where that arc is. You're going to take that same measurement and you're going to go to point A. I better read the directions. It's been a while. Let's see. Draw the arc using the same radius. Yeah, so same radius. Go to point A and mark off below. Go to B and mark off again below the line. We're trying to find a second point. It is. Now what I'm going to do is I'm going to connect. Do they want us to label that as Q? Here's our new point. We just found Q. And we are going to draw our line through PQ. That's going to be a perpendicular line. So we are going to draw a line through PQ. And we just created a perpendicular line, 90-degree angle. So now we have PQ is perpendicular to AB. Draw another line. That's not going straight across. Let's just draw any line in space. And I'm going to put point P right here. Remember not to mess up your radius because you need to use it twice. I am going to arc across from point P. I'm going to make an arc across that line. And then I'm going to use that same radius to go to my new points and arc off below. Go to this point, arc off below, go to the other point that I've created, arc off below, and then draw through that point. And again, I've created that right angle, and I could label that as my point A, point B, and Q. And again, say that AB is perpendicular to PQ. Example 2, one more page, and we're going to list those angles. One more page in your notes, corresponding angles. Angle 2 corresponds to which angle? They're in the same position. Angle 2 and angle 6. Next, we have angle 1 corresponds to which angle? They're in the same position. Angle 1 is right here. I'm looking for that same position on these angles here. There's angle 1. Which angle down here would be in the same position as angle 1? I've only got 4 angles. It's this angle here in this corner. Which angle down here would correspond to that? Angle 5. We still have more. How about angle 4? Which angle is going to correspond to 4? So just look at the first set of angles. I see that 4 is right here in this corner. That means that 8 would be in that same corner. One more. Angle 3. 3 is right here in the right bottom corner, and 7 is also on the right bottom corner. Alternate exterior. Exterior, Boston. Am I going to be on the inside of these two lines or on the outside when it says exterior? I'm on the outside. So now I'm looking for 2 angles that are going to alternate and be on the exterior. Which one for angle 1 is on the outside? Which one would be alternate exterior in the second group? 7 is on the outside, but is it alternating across this line? It's going to have to be on the other side of that line. Yeah, 2 and 7, good, are alternate exterior. 2 and 7 work. And then 1 and 8 would be the other set. All right, try alternate interior. Now we're looking on the inside of the lines. Name 2 sets of angles that are alternate interior. 3 and 5 are not alternate. They are interior, though. 3 and 6 would be alternating, and they're on the inside. I agree. One more. 6, and then angle 4 and angle 5. Correct. Okay, the last one is called consecutive interior. They're on the inside, but this time they're not alternating. They're consecutive. They come one after another. Angle 3 is the consecutive interior angle to what other angle? 5. The other one's what? Yes.